content of my speech will be about roads in the urban sky. Now we are talking about mobility, we're talking about cars, like this very interesting speech from Volkswagen. We're talking about flying air taxis. But what would these be without regulations and without roads in the sky? I'll touch that point in a minute. So I'm talking for the German Institute for Aerospace Standards, the DIN, and for the European Association for Aerospace Standards, ASD-STAN, which is a part of CEN, the European Standardization Organization. What do we have to do with aerospace, with autonomous flying? Now, DIN has a history of 100 years. That's really an old organization. Now, but we haven't invented the standards. It was actually much earlier than this. It was 2,200 years ago. It was a Chinese emperor. Qin Huangdi was his name, and maybe some of you have seen some things of him if you have visited Xi'an, if you have seen the Terracotta Army. That's the guy who planned all this. He was on the same side, one of the most aggressive, one of the worst dictators that ever were living on this planet. On the other side, he was a genius, because he was the guy who made the norms for wheelbase of transport cars, and he made the norms for the width of the roads. Today, our trains and our roads and our tunnels and our bridges, the main basics are going back to 2,200 years ago, because if he would not have taken care of the development of these roads, China would not have been able to start a real large interaction. It was the first infrastructure system that he built. He has built a road that was more than 800 kilometers long, going all the way to the north. And the width of the transport cars, it's very obvious. If you have roads, you need two cars that have to pass each other. So that was important to establish those standards. Now, today, the DIN, being a 100-year-old organization, maybe your imagination of this institute is like this here. You know, quite old, lots of paper there, lots of dust there. But what do we do with innovation? What have we to do with innovation? And actually, that's showing why standards and innovation are two parts of the same coin. If you want to climb up the mountain of innovation, you need the steps of standards to be able to climb this mountain successfully. That means without standards, we would always make innovation and fall back some years later. The DIN is going into a very new age. Now, we have a history of producing paper since 100 years. Now even PDF is paper. But now we are going to digital standards, to standards which can be interpreted by machines. It's no longer that people have to read the standards, understand them, and tell the machines what to do. In future, the standards can be interpreted by the machines directly. One example of this is we have a DIN spec, a very new topic, where we will define the standard to make digitalized certificates of conformance, which are very important for the aerospace industry, as lifetime archives and so on. Now, the matter in our innovation cluster, Innovationskreis of the DIN, is how do we provide standards for the future autonomous flying? And you see, it was mentioned from several people the Airbus project, which also, on the other hand, shows the Lilium project, and there are a lot of these things in between. But there are several applications for each of those projects, and I'm mentioning a Roland Berger study here. Roland Berger has said among the variations of the use of autonomous flying, one case will be the air taxis, and there are other cases. It's not all air taxis. So the one case will be air taxis because it will be on-demand, point-to-point, non-stop service from one destination to another. It will have a high network coverage and the fastest travel time between 2 points, which is typically for urban areas. Now, in order to visualize that a little bit, I checked the internet and I found this. Some of you will recognize it. Some of you will recognize that old movie, The Fifth Element. And it showed already part of what we are talking about here. Maybe it will not look exactly like this in future, but it gives an impression. Maybe it will look more like this photo from Lilium, having air taxis somewhere in the urban area, but maybe that project is not so valid for interurban traffic, because this is a part of the study of Roland Berger, and it shows the various concepts and why they do not overlap, why they have different applications. The multicopter project, for example, Volocopter is one of this. It has a very short range, but a high ability to hover, to take off and land within a small area and sort out small distances. It could be an air taxi for small distances. The quadcopter project, like the one that Airbus is developing, could be for urban areas and airport shuttle applications, because it can seat more persons. And then there are the hybrid concepts, but the fixed wing or tilt wing projects, and these, like the Lilium, are excellent for long distances because they combine the vertical takeoff and landing facility with the long range capability. But here we are talking about the urban aircraft. We are not talking about all the applications. You see that there's the large aerospace controlled by DLR, for example, DFS in Germany and others, and there are some other areas. We are talking about the urban air mobility, the very low airspace and confined to urban areas. One study, which has been part of the Airbus blueprint, shows that in the year 2035, they estimate that in a city like Paris, there will be about 19,000 autonomous flying objects overhead a city of Paris per hour. That's a lot, and you can say maybe that's not going to happen. We will see. But anyway, it's not so unlikely it could happen. Now, if you have 19,000 of these objects flying overhead a city, of course, you can forget that every air taxi is flying from A to B and the next is flying from C to E or something. We need regulations. We need something that this old Chinese emperor has developed. We need to develop roads in the urban sky. That shows the concept which is presently tested in Singapore, and Dirk was talking about it just 1 hour ago. But this method of having urban air traffic relies on remote controlling. That's a different thing. When we talk about so many air taxis and transport equipment in the air of large cities, we can no longer have some like remote control. It has to be autonomous, otherwise it wouldn't work. Now, there are some requirements for this autonomous mobility which are excellent for being covered by good norms, to have reliable basis, like all the network automatic operation and production. There are many aspects of which we need norms, like interchangeability, like basics that are valid for all operators and so. We need the norms which I call the urban roads in the urban sky. And of course, we need norms when it comes to artificial intelligence. I have already mentioned the digital norms that we are developing, the norms that can be directly interpreted by those systems. Now, a really dense population of autonomous systems will not be possible with today's computer technology. But as we speak, artificial intelligence and computing technology is moving on at an incredible speed. Once we have the technology of quantum computing, it will no longer be any problem at all, because the power of those systems is so tremendous. But I'm sure there will be no possibility to mix kind of private air traffic with autonomous air traffic. It has to be autonomous all the way through. And I'm talking about the urban sky, not anything outside. So we need norms that cover safety and security, which is definitely a showstopper if it cannot be reached for the whole technology. The airspace must be shared. There have to be standards to allow this separation. Drones must be allowed to self-pilot, as I said, autonomous flying. The fleets must be able to self-manage. That means, maybe some of you have thought in future we will buy such an air taxi or such a flying car and fly somewhere. No, I think we will not buy any of these. I think organizations, either private or public-owned companies, will operate these air taxis, will operate this equipment. And all you can do, you can buy the transport service. You can rent this as you enter a taxi, or maybe taxi is not the best explanation, especially if we think about German taxis. You take an Uber or something like this. Maybe that explains this better. Or in China, a Didi. That would also explain it. So you just use the transport. You enter a metro. You enter a tram or a bus. It will be the same for those. It will not be a privately owned aircraft flying around in this range. So those fleets have to be autonomous, and as Dirk showed the app for this helicopter service in San Diego, that will be self-managed. And the worldwide harmonization of this airspace and of this regulation is very important. Now, how can we, as the DIN in Germany or ASD-STAN in Europe, how can we arrange such a worldwide application of those standards? The answer is, about 5 years ago, we have already made a very strong cooperation agreement between the DIN, ASD-STAN, and our Chinese counterparts, the CAPE in China. And we have a very personal cooperation. And so the standards we will make here will tomorrow be taken over by the Chinese Standardization Organization. And maybe in that case, the Americans this time will have to follow us and not the other way around. Airspace must be accessible. What does that mean? Those roads in the urban sky, which is the title of my speech, they will not be made by the typical space authorities like DFS in Germany. In the urban sky, the authorities to build those roads has to be the the community government. It has to be integrated into the road system, into the metro system, into the whole urban system, and it has to be under total responsibility of the urban regulators. Because only, let's take Munich, only the Munich government will know which areas are safe for such autonomous traffic and which areas, maybe school, maybe hospitals or whatever, are no-go areas. So it's not the German aerospace regulator who has to do this. It is Munich, for example, or Ingolstadt, that's the other example, or Hamburg. And that's a real big difference, because at the moment all the discussions go about how DFS and others can make the regulations of this. And I think it's the wrong way. Only the urban authorities have to have the authority over their lower airspace in order to define those channels where you can fly, and maybe we see it on the next slide. Here you see such an example. You see the for example, delivery hub zones. We have seen such a similar photo recently. The airport zone for the airport traffic. But this is the urban zone. And in the urban zone, there have to be corridors, very precisely defined corridors, like Jinji Huangdi has done 2,200 years ago. Corridors which specify the size, which specify, of course, also the speed, red lights, all kinds of things. The whole flying within these corridors will have to be organized by the autonomous flying vehicles based upon rules which are made by the urban government. So, of course, such a corridor will always only define traffic in one direction. So within the corridor, those systems are safe. There will be distance rules. There will be rules like, are these corridors in an area where you have a full cell coverage for the mobile, like 5G? Below 5G, I don't think it will be possible, for the reception of mobile radio. Because if there are areas which are in the shadow of mobile radio, it is a definite no-go of flying, because those systems need also to be monitored. If we have such rules, they have to be enforced. That is why the standards, for example, need to be taking care of remote identification. The comparison to a car would be the number plate. Here it is an individual. Here it is a identification, a digital identification, which should be the same in Germany, France, Netherlands, Spain, and China. No difference in those rules for identification. The mobile radio quality I have already mentioned. The interfaces have to be standardized. Data encryption is a very important topic, and it has also to be done in a standardized way. For the observations of traffic rules, we have to have some norms, and the documentation. The documentation of autonomous traffic is extremely important, because those systems are flying in the airspace. If any time after something comes up, every movement of those systems has to be recorded. And that is why this will be an important point. Another reason why documentation is important is the basic that I said in the beginning. It will not be private cars flying around the airspace in cities. It will be fleets of organizations. And of course, you will have to pay for this. And in order to have a safe payment basis, you need documentation to establish that. After 2030, and that is again a summary of Roland Berger, after 2030, he says that all this will turn into safe flying robo-taxis. A nice word, I think. And the capacity of the vehicles will be raising, and the range will be raising, like 10 persons per aircraft and up to 300 kilometers. But this will be outside of the urban cities, like I said in the beginning, more the fixed-wing aircraft. And maybe small intercity airline operators could emerge, new companies could come up. But one aspect I want to draw your attention to, from a technology point, this all sounds really exciting. And I really hope, Yvonne, that one day I will be able to fly such an air taxi. You know that I'm a pilot, but not yet with these. Wilfried, maybe you want to fly one of these as a licensed pilot, but maybe as a passenger at that time, autonomously. But in order to really benefit from this technology, we have to have an overall positive reception from the society. Now, if those air taxis would just be affordable by the wealthy people, I don't think that people would accept the downsides of this. Some additional noise, for example, or other inconveniences. Society will say no, and then society could kill that project. That's why I emphasize, let's make sure we work in a direction where it's really usable for a wide range of population. It must not be expensive, otherwise it will die. At the moment, we are in the development age, as I said it before, we are in the development age of these things, although they look already so nice, but we are in the age where if you see the old black and white movies of people trying to build the helicopters, you know this thing here, it never came off the ground. We are somewhere there, which is not bad, because in some years we will be further. But we are not ready yet to install it tomorrow, or maybe in 3 or 4 years. But development, of course, goes much faster than it did at that time. You know, before they built this crazy helicopter and all the things which fell apart before they could take off, several hundred years before that time, or maybe 400 years before that, the first helicopter was designed. Does anybody know who designed the first helicopter? Yes, it was Leonardo da Vinci. And it took about 400 years from the first design to the first flight. And now it will not take 100 years or 400 years. It may only take 20, hopefully 15, or more hopefully 10 years. But it will not be tomorrow. GeoGuiding shall enable a safe traffic of an autonomous equipment, and it doesn't matter if it's flying or driving. Although Dirk said that concept is presently put on hold. Yes, maybe it will be brought up again. GeoGuiding will enable a safe traffic overhead the urban sky. And therefore, maybe in some future, we see something like that. And more important, we can take part in the benefits of something like that. Thank you for your attention.